what I did here was just measure all the dimensions on the part. The ID first, using the worm tool, rotates around the part, automatically follows the contour. It'll develop the 0, 0 in the center of the part. Then I went around and I did the OD. Did the same thing. I know you didn't ask me to do that, but I'm just trying to measure everything so at least we could see how long it would take and whatever. Now, this particular system here is an AV300, which is a stepper motor system. We also have servos that are a little quicker and linear motors that are even faster. So, depending on how fast we need to do this. Actually, when it does the rest of this, it'll be pretty quick, as you will see. So basically, it's taking 1,000 points on the ID, 1,000 points on the OD. Then it's going around and actually measured all the circles too. So it just bebops around and measures those as well. I didn't know whether those were of interest, so I measured them. Then what I did was, as you'll see in a second, we'll go and we'll start measuring the ball track, sides of the ball tracks, each one. And basically what the machine does after that is it establishes the center line of the ball track based on those two lines. Then I take a target point out in space that's at the end of the angle for that line, and then establish a line so you can visually see it, as you will see right here. So basically what the machine does is it calculates those lines. I put in angular tolerances just to show you what it would look like, good or bad, red, green. I don't know what the specs are because I don't have a drawing. So you can see on the point basically what the machine is doing is it's measuring, measuring the angle between one line and the other all the way around. Those points were developed based on the angle of this center line here. So I basically got this center line and projected a point out in space here, and then I connected the two from this line to that point. If we look at these from a magnification standpoint, just so you can see it well, we have the video running here. If I take the points, one of the points, blow it up here. Okay, that was just one of the points. Let me see if I can come back over that a little bit. There we go. That's the wrong point. Hold on one second. I'm trying to get the right point, which is then one of these, so it would be this point. Let's try to do that. Okay, so here's an intersection of a point out in space. If I can bring this in, I can show you what these points actually look like. Sorry, my finger's in the way. But these are the center points, the centrality, I guess, of the angles of those different lines. And you can see, although that looks pretty gross, it's it's the distance. Just to give you an example, if I took this point, well, I can't do it with one hand. So hold on one second. If I took that point, if I took one of these points here and I took another point, sorry, I can't do it with one hand. Anyway, this distance isn't that great. The objective here, though, is to see how fast the machine actually goes and does what we need it to do, which is it's pretty quick. It can do it much faster and much more repeatable than anything you can do by hand. So anyway, that's the basic video of what we're looking at here. So I'm going to forward this on to Alex, and we'll go from there. Thanks.